Cool. So, thank you very much for having me here. It's my first Hackference ever. So, my name is Mircea, and I work for a company called Cloudflare. It's a CDN. I'm a network software engineer, and I also member and maintainer at Napalm automation community. I have integrated this Napalm we'll talk about a bit later into a framework called Salt. I'm also a representative of a community called OpenConfig, and sometimes I blog at my website. That is my name, my complicated name.net. Also, I'm on GitHub and Twitter, the same username everywhere. As you can tell, I don't have too much imagination. Yeah, so I do not represent my employer, but I kept this slide because I want you to see what's the size of the things I'm going to talk about. So Cloudflare carries has behind 7 million of websites. We serve about 200 millions of internet users, and is the largest facet. I don't know what DNS core is. The idea is that we have a lot of traffic, and if we screw up something, everyone will know about it. I'm going to talk about what is the internet, what is a network device, and what are our challenges as network engineers, how we can hack the network devices with something called Napalm, is an open source Python library, then how we integrate this into an automation framework called Salt, and how we hack the networks, and then at the end I will have a very short example. It's not a live demo, it's only some text. I can't push some live demos. So before getting started, I want you to know that we'll hear many things. I just assume you don't have a deep network background, so don't be afraid. I hope this will be a trigger for you to go a bit deeper and study. I will be happy to give you some more materials and look into it. So what is the internet? Take out of your head the idea, if you have it, that the internet is the same as the web. The internet is the hardware infrastructure that keeps the web alive. So if you ever heard about the SaltStack, the web is somewhere at the top level, is the application layer. We talking about here about the rest 6 layers. We have we're talking about network devices that are connected. Here, this is an image of the internet. I just took it from Wikipedia. These are small networks, and they are interconnected. And all these many networks interconnected forms this internet. You can see one here. This is about a network and is interconnected with others like that. And what is a network now? Is a couple of network devices that are interconnected, either using a cabled or wireless connection. For example, we have a network here using this guy that forms a wireless connection. But the internet is about mostly cabled connections between devices that big. And a network device is this one as well, but depends on the size then, and this reflects the amount of traffic that they can carry. It can be a little bit bigger than like this one, or that big, or taller than myself. And in this case, the size matters, because the bigger the hardware, the more physical ports you can get in. That means more traffic your device can carry. But at the end of the day, they all have the same thing. There is some hardware with some software on it that you need to configure. And what you need to configure, you can configure, I don't know, like the list of NTPPS, BGP neighbors, the firewall, OSP interfaces, and so on. If these two are Chinese for you, don't worry about it. It's something you have to configure and to make it work. The same, you need to retrieve data to see if your interfaces are up. The BGP neighbors you configured are connected with your other network at the other end, or your network is NTP synchronized, and so on. So it's about also to configure a device, but also to check if your configuration you applied is okay. Now, these devices are produced by someone. Unfortunately, we can't produce it ourselves. And in this world are a couple of, there are so many network vendors. Some of them I didn't hear yet myself. There are plenty. They pop up like mushrooms. Like maybe you heard about Cisco. Another big one is Juniper. There are many others. Arista is also a big one, and so on. And that's the definition of network vendor. They produce the hardware, and the software is able to run only on their hardware, mostly on the traditional vendor. And they are mostly interested to sell you this product. Here's your product, and we don't care about it anymore. But they also offer support, and most of the time they, of course, is a software, and software has bugs. And they acknowledge it, but unfortunately, it happens very rare. They even fix them, even if you pay continuously, these guys. And are they consistent? No, not at all. All these vendors is a complete mess, as you will see in a bit. Here is the configuration on a couple of platforms, like Juniper, Cisco, and Nokia. Yeah, Nokia still exists. And this is how you configure something called the BGP neighbor. You don't focus on what you configure here. Focus only the differences. As you can see, this is how a configuration looks like on a Juniper on the left-hand side, in the middle on a Cisco, and on the right-hand side on a Nokia. They all say the same things, believe me, but they look completely different. Now, when you want to look into what you have configured, you want to look at what happens with one of your BGP neighbors. The device presents you data in this format. You have, it tells you the peer, the type of the BGP connection, and many other details. Won't go into these details. On a Cisco, doing something, executing a similar command, but is when you type something completely different, will show you the same information, but in a totally different format. If you go to Arista, again, it is presented in a completely different way, and so on. Now, to interact with this device, they offer sometimes some APIs to get this data or to push some configuration changes. And Juniper offers an API that is XML-based over something called NetConf, is a proprietary standard. On a different platform, Cisco called ISXR, they offer just XML over SSH or Telnet, which is already pretty bad, but can't do much about it. In the last version, they offer some JSON over gRPC. gRPC is a protocol from Google, but this is only on latest versions, but only if you're lucky. It's a weird combination of hardware and software we need to have, so they somehow want you to force it to buy more products for them. Cisco IIS are those common little boxes like that from Cisco, black boxes. We've seen a couple of slides earlier. They don't have any API at all, so only what you can do is connect with SSH and screen scraping. Is as terrible as it sounds. Is also NXOS has an API that is JSON over HTTP. Arista again JSON over HTTP. That one is quite good actually. Okay, so Cisco NXOS. I said it has an API. Thanks God it has, but is quite bad. And as you can see, the version number on a Cisco NXOS, that is the operating system, the version number is, they don't understand it themselves. I mean, there's a whole manual explaining the versioning system. It's a complete mess. And between minor releases, they make many changes in the output of this API. As you can see here, this field administrative state, it is in 7.0, but it's not in 7.3. And that is a quite important thing. This one has changed the format from 2 days and 13 hours to this weird thing when it could be just a timestamp. another one, the Ethernet, the speed is 10 gigabits per second. Here is 1,000 megabits per second. Of course, it's the same thing, but it's text when it could be just a number. And now, you know much better than me probably that this is not a valid JSON when you want to look at some data. Or XML, when you load a request to a device, and XML, it throws this error which you give it back as just a plain text when it could be just inside some XML tag and so on. Now, these devices usually just get it and you can configure it. Most of the time, we are not like a server where you can install anything you want. You just take it and pay the money for the guys. Traditionally, you can't install software you want. But there are something called Whitebox devices produced by guys like Arista or Cumulus, where you can install, however, some software, but not everything. And usually you need to provide lots of backports, like Arista AOS is based on Fedora 14. Can you imagine this? I mean, do you know, how many of you know the latest version of Fedora? It's Fedora 26, something like that. So this is 14. Yeah. Yeah. And this is, to sum it up, when you have a multi-vendor network, you have all these things and so on, not only between when you have the same platform and you can have inconsistencies, but you have inconsistencies between those vendors. And also, each vendor introduced their own standards and so on. This is why the network community come up with this library called Napalm, because why Napalm is actually forced to be an abbreviation that makes sense, because we said we want to burn these networks with Napalm. Yeah, it stands for Network Automation Proprietary Abstraction Layer with Multi-Vendor Support. And it is an uniform API that normalizes all those weird outputs from the vendors, and using different methodologies, XML, screen scraping, or JSON, and will present you everything in a uniform way. Blindly, you do the same thing. You only say, I want to get data from Juniper or Cisco, and you do exactly the same commands. The only thing different is here. Everything else is uniform. So when you get the BGP enables, as you've seen from the device, they present you in a totally different way. Using this Napalm, you will have everything, the same fields, and everything is unified. Now, about the operations of the DevOps in the network teams. The challenges, leaving aside what we presented so far, is about provisioning new devices, is to react to certain events and reconfigure eventually. And network environments are super dynamic, meaning that you can have internal events when your device complains about something, or external events when someone, for example, roots leaks the entire routing table on the internet to you. Then your interface is a bit screwed, and your devices might not handle this amount of information. Or like every other human error factor, when someone has a typo and can break the entire network. When we need to replace, the hardware again has bugs, and it can be faulty, and from time to time we need to replace that hardware. And also to monitor. In DevOps, people use a variety of frameworks. Those four seem to be the most adopted. Ansible, SaltStack, Puppet, and Chef. Does any one of you use any of them? Yeah. We at Cloudflare have been starting using Salt. Why? Because it's very scalable to handle our amount of devices. We have a couple of hundreds of network devices spread all around the world. We have a pretty big team now, and our network engineers need to access those resources in a concurrent way, meaning that all or a couple of them want to do the same thing, and we don't want to step on each other's foot. Salt is also an event-driven framework, and it's easy to configure and customize. It also caches some important details. I'll give you an example. LLP neighbors can be cached, and you don't need to retrieve from the device to stress the CPU too much. Also, we like Salt because it has very good documentation, and it's one of the friendliest communities, and believe me, that really matters when you want to deal with friendly people, not assholes. And we like Salt also because it's quite fast. It's also a difference between orchestration and automation, meaning that you automate a device, you handle or you manage the configuration of a specific device. But in networking, it's very common that managing the local configuration of a single device is not enough because you need to propagate a change across many devices. Otherwise, things won't work perfectly. And another reason why Salt, because it's used by many large organizations around the globe, like LinkedIn, Adobe, SAP, DigitalOcean, and so on. The one disadvantage of Salt for the network devices is that it's not agentless. Because on the server side, when you want to manage some servers, you install something called Salt Minion. It's a software. You install it on the server itself, on the server you want to manage. But as we said, on a traditional network device, you can't do that. This is why they have introduced some time ago, like 2 or 3 years, something called Proxy Minions, that they inherit all the characteristics of the regular minions, but they run locally on a server somewhere, doesn't matter where, and they connect remotely to your network device. And we'll connect using the library we talked about earlier called Napalm. And we mix them together, and we have officially integrated that library called Napalm into Salt, and already 2 releases called Nitrogen and Carbon, and are many features around. And now, from using Salt and this combination of Salt and Napalm, you can execute commands, arbitrary commands against Junos router or IXXR router, and they will present you the same output no matter what, and no matter how crappy is the vendor or the platform. In this example, it retrieves the ARP tables from Junos and ARP. You can see it has the same output, the age, the interface, the IP, and so on. The only difference still is here in the interface. We can't quite normalize this. But anyway, the network engineer, when it looks at this, it needs to identify exactly what interface is there, and so on. And similarly, also when you manage the configuration, you execute the same command against a variety of platforms. The only difference is in the output that is presented in the native way the platform deals with. I was saying earlier that Salt is an event-driven framework, meaning that absolutely anything that happens inside or outside can go through an event bus. For example, when you run the command I exemplified earlier, net.arp, that retrieves the ARP tables, this is going to push an event on the Salt bus. And this Salt bus is pluggable, meaning that you can import events from external sources. And in this case, we can import events that are from internal of the network. And this kind of events, being like an NTP server, is unreachable. You can inject this event directly into the Salt bus. It has this format, it's a JSON document, and then you can interpret it. Salt has something called the reactor system, meaning that when it an event occurs, like here, we say when you have an NTP server unreachable, do this, and will trigger and will execute a state, which is basically the equivalent of the command we've seen here. So all the things is, can happen happens automatically. If we look at the global picture, we have an NTP server that becomes unreachable on a network. It is a notification directly from one of your network devices, and then automatically something happens behind and will reconfigure that router. I hope this doesn't sound too much like Chinese. I'm sorry if it does. But as I said, I hope you will be interested into learning this. I started as a software engineer. I'm still a software engineer at heart. And believe me, it's not rocket science. Networking is not, it's just many things you have to learn and bear in mind. And it's certainly something you can do, and I encourage you to start learning. It's a nice field. It's exciting. I have here some references to Salt, to network automation, and some others. But if you want to learn more about networking, just drop me an email. Here's my email. And I'll be happy to provide you with materials. And also, I have some virtual machines directly from the vendors, from the platforms you can play with. And I will make sure that you learn, you make the first steps, and why not start automating and helping the network community. Would you like to? Yeah. You can also join this Slack channel, network2code.slack.com. That is the place where network engineers that have some interest in software are. Is the opposite. Most of network engineers have no idea what is, never wrote a line of code. So it's a great place if you want to get started and help, and also exchange experience. You can learn them code, they can learn you networking, and so on. I hope this can work. Would you have any questions?
So are there any good pieces of software available to say, so if I have a virtual machine that I provision with something such as Vagrant, are there any good pieces of software to automatically network together lots and lots of Vagrant machines that I've got up together on my local network?
Yeah, I use Salt for this, but there are many others, like Ansible is excellent as well.
For example, Salt could be put into my provisioning script to make sure they connect just like that?
Yeah, it's quite easy, yeah. Salt is more used if you want something that automatically reacts to different events, but for example, Ansible is much easier to do something like that. Ansible is quite easy to learn and start with, and yeah, if you want only this, I would recommend Ansible, for example. Yes? Go ahead.
How do you go about testing the changes that you're making? You say that you use Napalm and it will push it out to multiple devices. How do you make sure that it is actually going to do what you think it's going to do? Yeah,
we have a continuous CI pipeline for this, because it's a great responsibility. It's about 10% of the internet traffic, so we don't want to mess with that. Yeah, and certainly we have a pipeline that checks all the things before someone pushes any changes, and also peer reviewing and all the things. Yes, go ahead.
Can you give us a quick summary, or maybe point us towards some resources that will give an idea of the different use cases or implementation between something like Salt and Ansible, like what the differences are between the four main provisioning tools that we've mentioned?
Okay, so let's go here. Yeah, the main difference between Salt and Ansible is because Salt is an event-driven framework. It has a bus. Ansible, on the other hand, is very easy to start with. It's quite simple. Someone said at some point that you can get started in like 5 minutes. On the other hand, Salt, if you want to dive into it and get very deep, you can't quite use it as a hobby. You need to work on it every single day. It took me a couple of months to understand what happens under the hood. but it comes with many features already built in, and most of the time you end up reading tons of documentation, and you'll write 2 or 3 lines of YAML. Yeah. About Puppet and Chef, I don't know. I know they are very good. They help tons of people, but I never use them.
Sure.
Yeah. Yes?
I understand Salt requires it's a master-slave configuration. So
Yeah.
you push your Salt configurations to one place and all the slaves can connect in to all your updates. Is that right?
Something like that, yeah.
How do you stop, if you've got 1,000 network devices on your network, how do you stop them all performing the same update at the same time and potentially causing downtime for your infrastructure?
I'm not sure I understand the question.
So how do you make sure that if you've got, say, 1,000 devices that all require an update,
Yes.
how do you kind of time box them so that not all the devices update at the same time, or do you?
Salt is asynchronous, so it's actually quite the opposite. The master sends a broadcast command to all the minions, and when the command matches a minion, I want to say that minions will ask themselves, do I match this target? Because in the payload, the master sends, I want to match these minions. For example, I don't know, I don't have any examples here, but I want to say, for example, all devices that are Juniper, okay? And this payload will be received by all possible minions. And each minion asks himself, do I match this target, yes or no? And then we'll reply and we'll send back the answer to the master. And everything happens asynchronous.
Yeah, but can you defer, say, could you say 50% of the devices update in the next hour and 50% of them update the hour later so that you don't just
Yes,
all
yes.
of them spamming?
Yes, depends how you want to make the targeting. The targeting is already a super complex topic. You can have targeting depending on their characteristics, on the name, on what data you want to configure on them. And then you can either have a scheduler that say first half executes now, the second half executes in half an hour. Or you can also have batches. When you execute this command, for example, you can add here -b, 20%, and we'll execute the first 20%. When it finishes the first 20%, it executes the next one, and so on.
Okay.
Is a couple of choices. Yes?
What would you advise developers? So, if some developer does not know much about networking, what would you advise them to do to get more knowledge in networking? Any particular books or?
There's an excellent old book by Andrew Tannenbaum that introduces you to the basics, to learn what is a MAC address, what is an IP address, and all of sort of things. And while we have these basics, I recommend starting with one of the vendors provides for their certificates. I don't recommend taking vendor certificates because you will be locked in, but to focus on what they teach you, leaving aside what they say, hey, this is our CLI, how cool is it? But to focus what is behind and understand how things glue together. If you send me an email, I can point you exactly to these things.
Okay, let's let Mircea and everybody else go to lunch. So give him a huge round of applause.
Thanks.